So the front end is, let's say, the HTML, CSS, and JavaScript. The CSS and JavaScript are going to be really clear to anyone who's ever done any front-end web development. The HTML is mostly the same. There is a slight little twist, which is that it uses a templating engine called Ginger 2. Anyone come across that before? Okay.
Only in the context of...
Okay, right. So...
Quick question.
Yeah.
I'm sorry if I missed this, but can we access these slides somewhere, or?
You will be able to access them at some point.
Okay.
They're still somewhat in flux later on at the moment, but we'll definitely make sure you get a copy of it along with any presenter notes by the end of the workshop.
Okay.
So you don't have to write everything down, but just things I mentioned on that. So Ginger 2, we mainly use it to avoid boilerplate in HTML. So there'll be a layout HTML page that defines the head tag and the various bulk bits of navigation. And if you want to override one page and only override one bit, the block system means you can do that without having to copy and paste code. It also makes it so that it's a lot easier to customize things because you only have to change them in one place. You don't have to go to every single page and change them there. The front end is going to be mostly separate from the back end. Ginger 2 allows you to say, I want the result of this Python function call to be included in the template. You can absolutely do that. We generally don't use it very much at all. We mainly focus on people exchanging data with Dallinger through the JavaScript API, which is all Ajax-y goodness, but you don't really have to worry about that because the common functions are all wrapped up in a library that we provide to you. And the main thing that you're going to be passing back and forth, it's called an info. You can pick what you want to be in there. You saw earlier that we had SVGs and PNGs in the Bartlett 1932 demo that you ran yourself. It uses the text that you type in. Anything that you can reduce to text format, you can put in there. It's common to use JSON, but plain text works as well, or anything that your front end might happen to use. The front end is mainly in two directories of the experiment. There's the templates directory, which has got all of the HTML, and that's the place that is introspected by Ginger 2 and is used for deciding what URLs exist and how everything's found. The other is the static directory, and things in the static directory are just there. They're available on the experiment, but you don't have to do anything special, and there's no special processing can be applied to them. The static directory is in your experiment is a layer on top of the one that ships with Dallinger. So in Dallinger, you will get some things by default. There's a favicon, there's the Dallinger JavaScript, there's jQuery's JavaScript, these sort of things that you're probably never going to change. If you do want to change one of them, you just put a replacement in the static directory. So you don't have to go in and copy everything over, you can just add files as and when you want them to be different. And in the HTML, the files that represent each page will start off with a line that says what file they are modifying. By default, there will be base/add HTML, for example, for the add page. That's because the template directory also overrides the Dallinger ones. So if you do add HTML, you can no longer say extends the add HTML from Dallinger because you've overridden it. So we have a special directory that you will never need to create a base directory yourself. Base is just where we store the original things if you want to refer back to them and extend them from your own templates. Is that clear? Okay. So this is what the Bartlett 1932 experiment looks like on the file system. I did cut out a few extraneous files like README and things, but that's generally what it looks like. So in templates, you've got the add, the consent page, the experiment, the instructions, and the layout. The layout is just the general structure of the page. And the add, consent, and experiment pages will be, and instruction page will all be quite familiar from having run through it. The add page is the first one. We'll go to that in more detail in a moment. And the static has got a bunch of other things. Stimuli are bits of static content that are important for the experiment. They're not overriding something in Dallinger, they are experiment specific. Scripts have got experiment specific JavaScript in there as well. Nothing from Dallinger has been overridden. But you'll notice that the logo PNG and the favicon.ico are things that are overriding from Dallinger. So there's one namespace, you put in everything you need, it overrides it from Dallinger if it's already there, otherwise it's available. So add HTML. We've looked at the ad a couple of times, especially when Nori was showing us the Mechanical Turk sandbox. The ad performs two duties really. The first one is it's what shows to users when they first come into Mechanical Turk and they have not yet accepted the hit. So this is a sort of a general explanation for users who have not yet committed to being part of the experiment. And the other job that it provides is the view for people who have accepted. So as soon as they click accept hit, the page reloads and they get a slightly different version of it. The one that tells them you're going to have to click this button to proceed, the button appears, it will probably have the ad block warning. So there's two stages to this. And the default text is pretty good. None of the experiments I've done, I've changed them. People who've done live experiments, have you ever customized the ad HTML? No?
What?
Have you ever customized ad HTML when you've done a real one?
Yeah.
Okay. So what kind of changes have you done to that?
One thing that I found useful is if you're using a method in which most of the payment goes to the bonus, you basically literally need to tell them how much bonus is going to be there. So one change that I do often is tell them the bonus. Another thing that I tell them is the total time, because that's also in the way I do is not indicative to what's written in the ad. So you tell them, okay, that's going to be an ad, it's going to be like taking between 12 to 14 minutes, and that's going to cost, you'll get from it $7, $6.
Okay.
And another thing, if you have special requests for, like, I'm using auditory tests, so I ask for headphone, then that will be a good place to kind of ask them to use headphones. Then you can use other ways to test if they are using it. But at least if you tell them this thing requires Chrome and headphone test, they cannot complain later and say, hey, I don't have Chrome and headphone.
They can and they do, but probably less.
Yes, they will, but you have a different in response that you will.
So yeah, to do that, in your experiment, you would open up the templates directory and you would open the add HTML page. And if you have Bartlett up at the moment, I think if you do that, it will probably just say extends base add HTML. So that it has. This is part of the base add HTML. You'll see there's a if at the top saying if the assignment ID is not available, then show the no assignment block, otherwise show the live assignment block. So you don't need to do the if, but what you can do is you could take that block no assignment, end block no assignment, and put that in your page directly under the extends. And what that means is it will load the base that has been extended, but use your version of that block instead of the one that's programmed in. So to change the text that's displayed when you are when someone who has not yet accepted the hit is looking at it, you would add block no assignment, you'd add your header and whatever arbitrary HTML you wanted. And then the second one is the live one, so you would do exactly the same thing for people who have accepted it. The caveat there is you have to make sure that you add the begin experiment button, because if you don't have that button, there's no way to actually get to it. But it means you can style it if you want. You could add a bit of text afterwards or move it to the right, whatever you wanted.
And having the button means the ID needs to be right? I don't care about class, because that's like just style of.
Yes, that's correct. So it needs to be button, type button, begin button. But you could, for example, change the text of begin experiment, especially if your target language is not English. That's a really useful thing to do, because people expect the entire thing to be in the language that you want them to interact with. Consent.html, this one I think everyone will have to customize because it's what tells the user who's running the experiment, what your data you're collecting. At the moment, I think it just says a postdoctoral researcher at XXXXX, something like that. So that works exactly the same way in your consent HTML that you are given in the template, in the examples and the demos. It will say extends base consent.html, and you can do block consent text to replace the text that is displayed in there. So you don't have to worry about the container, you just add a bunch of paragraphs, maybe an image if that's appropriate. And there are two more. There's consent button and reject button, and they are the bits of text, not the entire button, just the text that's shown for the I agree and I don't agree buttons. So that allows you to more easily say that this is the version in this language. You don't have to recreate the entire button with this page. With all of these, if you go into the Dallinger code on GitHub or you download it yourself, you can look at these pages and you can decide, actually, I don't want to fill in the blocks that have been done here. I want to replace the entire thing wholesale. It's pretty unlikely that you'll need to do that, but if you ever do need to, that's what you would do. There's Questionnaire, which we did not have in our templates in the one I just showed you. So that one is completely unchanged. But the Questionnaire is, at the end, remember there was those two drop-downs that said how engaged were you and how difficult did you find the task? That's what the Questionnaire is. And that is entirely defined by your JavaScript and by your HTML. So if you add a new question or you remove a question from the Questionnaire, that data will be stored. You don't have to go in and declare that there's a new question in the back end. The two that you saw were in by default. You can add new ones above them with the questions block, or there's the replace questions block, which does the same thing, but it gets rid of those two. So if you don't want those two, you fill replace questions. If you want others as well as those two, you fill in questions. The data that's submitted just gets stored as question objects in the database, and then you get it as questions.csv when you download the data. As I say, it can be anything you want. You could even, if you wanted, use JavaScript to decide what questions show, so you don't have to show the same set of questions to every user. And also, there is a bit of a plugin architecture entry point here in that recruiters can decide whether they want to accept a questionnaire response from a user or not. So by default, the only thing that we do there is if a user returns their hit on Mechanical Turk and they still have the questionnaire open, anything they save will just be discarded. But that's because we don't really...
Can you explain when you do replace, if you want to replace those questions, and then you have also even want to add new questions.
Yeah.
So you just create a replace question block, and inside of that you would have a question block.
You can do that. You don't have to. You can just
Like
put them directly
like
in.
put somewhere in the top replace question empty block, and that will basically delete these old questions.
Yeah, and then if you want more questions inside that replace questions block, you would just put the HTML, which looks like that. So this is the HTML for the how engaged were you question. So if you imagine there's block replace questions at the top and end block replace questions at the bottom, that would mean that this is the only question that is shown.
Yes, but if I want to replace it, so what I need to write is a block of replace question in the beginning, and inside this question, other questions, the
Yes.
one that I want to add.
So
I just take this replace button and write my own question.
yes, exactly.
And what is the minimal component needs in terms of something about the ID or anything like that?
It must be a field. So you can have any HTML input or select or options or radio buttons. It doesn't matter what they are. It just has to be an HTML form element with a name.
With a name.
Yes.
Yeah.
And it can be any arbitrary name.
Because we had a bug the other week where we just didn't put a name,
Yeah.
and then
So ID is the way the JavaScript references the question on the page, and name is the value, is the key that it will be sent as when the HTTP request is sent. So if you have two questions with the same ID, so it's with the same name, you might have issues as well. So you should have questions that all have a name, and the name is always unique.
So the idea is basically, well, if you don't have a JavaScript, you still need an ID for the JavaScript to work.
You don't need an ID.
Yeah.
If you have an ID, you can style that directly with CSS, or you can write JavaScript that works with it. But the minimum you need is a name.
A name and some answer.
Yeah, so you could have I guess the minimum you could have is a input type equals text. Actually, you could just do input because the default type is text. Name equals thing, and the users would see a text box with no label, no hints whatsoever, but anything they typed into there would be stored in the database as this participant said thing was this. So it's your responsibility to put the label on, and it's your responsibility to make sure the users understand what it is. But
and one more thing that I think is new for, at least for me, for previous version of Dallinger, that somehow previous version of Dallinger, what happens is that each question was a separate kind of question.
Mm-hmm.
And I think now the default behavior that this entire form is saved as a JSON, which is much better.
Yeah, I think what we did was, rather than like hard coding a specific list of questions, we used an existing maybe jQuery or other method to pull out and serialize the entire form content. And so now it just serializes the entire form and puts that in a single row.
So
Yeah.
that's a change with respect to previous version of Dallinger, whoever feels that, but well, very welcome change, I think.
But the upshot of this means, because you don't have to write any Python, all you need to do to collect more arbitrary data about how the experiment went from a participant's perspective is add the HTML. There's no registration of the question type at all, just it will get saved. Is that clear? So those are the default pages that you might commonly override. There's also experiment.html. I didn't really describe overriding that, because in every single case you will write your own experiment.html that actually does what you want your experiment to do. There's no real useful default there. There is some stuff that you'll see in your demos and the skeleton code that we'll create later. It will all be pretty self-explanatory what you do with experiment.html. So theming. Dallinger's a pretty white and grey nondescript thing by default when you run the demos. That's might be what you want, or you might want it to be a bit more like what that branded in your institute's way, for example. So this logo is the default logo that you see when you ever start a Dallinger experiment. It'll be on the side and favicon in various places. You might want to change that to be the logo of your university or your research group or your company, whatever. And that's one of the things that is in the demos, like Bartlett 1932. It's just it happens to override it with the exact same one that Dallinger uses. So that particular override in Dallinger in Bartlett is not helpful, but you would put your own logo in here. It can be any PNG, it can be any size and any aspect ratio, but if you make it really big, then it's going to be really big on the page, so it won't look right. It's pretty easy when you do Dallinger debug to see, does this look correct? If not, give it a bit of a tweak. If you want to do something a bit more complex, like if you want to include some alt text, which is probably a good idea if you've got any text in your logo, or if you want to have multiple logos, you can fill a slot called lab logo. And the way you would do that is just the same way that we extended add HTML to change the ad page only. You extend layout.html, and layout is the one that all of the pages extend from eventually. So when you customize add HTML, it extends from base add HTML. Base add HTML extends from layout, and layout extends from base layout, which is a pretty convoluted thing, right? But what that's saying is that in the base directory, there's a layout, and that is the one that ships with Dallinger. And you can customize that layout in templates layout HTML. And any customizations you use there will be used by all pages in the experiment, whether or not you have customized them. So in that, you would do extends base layout like you did with add HTML, and I believe actually in Bartlett 1932 and the other demos, it has this already in for you. And you would do block exactly the same way that you change one block in these pages otherwise, but that block would be lab logo, and there you'd put in the HTML for your logo, or logos, or YouTube video, whatever you were using in place of logo PNG. And the favicon works the same way. There's a file static favicon.ico. If you replace that, then that will be the one that's used up in the tab bar or on the browser. Go on.
So just make sure that I understand. I want to customize layout.html. So I just go and write my own layout HTML. So for example, if I want to customize lab logo, I would go to layout HTML. It's going to be extending layout base layout HTML, right? Because this is layout.
Yeah.
And then I just replace some component there, says say lab logo with my texts and image combination of those, right?
Yeah. So.
And then basically it's just gonna just work because everybody extends layout, not layout base layout. Right?
Yeah. So if you just want to change the icon, this is the Bartlett 1932.
Yes.
You go to images and logo, and you replace this file. If you want to change in more detail, change the HTML that's used and not just the file, in templates you go down to layout, and here it's extends base layout. So in this one, what we've done is we've got a block title that changes the title to psychology experiment, and we've got a block libs. Super is a special thing that says use whatever was in the block I've just replaced and add in these two. So what you would do is you'd create a new one of these, call it lab logo, and have something like that, and that would change the logo for everyone. And this is layout HTML, and as you say, here in add HTML, we're extending base add HTML. Base add HTML extends layout, which itself extends base layout. So there's 4 layers of customization.
Right.
And this one overrides anything in the default layout. But because it's used by the default pages, it will still be used for the pages that have been customized.
Cool.
Any other questions on the logos or how the template inheritance works? Is it clear how the template inheritance works? Cool.
Oh, wait, it sounds clear, but then I try it and it doesn't work.
Oh,
So.
okay, what happens when you try it?
No, so maybe I missed. Where do I change them so it will work on the Bartlett demo?
In the Bartlett demo that you're running, if you go to templates, then layout HTML.
And then it only says the extends from base.
It will have extends base layout, and as I just showed here, I think it has a block title and a block libs.
But if I go to base layout, I see what also other things are available, right? In theory, there might be other blocks.
Yeah, base layout. If I go to
The base layout in the
So the thing is, like, imagine that there is in the base layout, the base layout contains a number of those blocks. So if these blocks are used all over the place,
Okay.
but if you go to the layout and replace one of those by your own new stuff, then it will make everybody else using that particular one instead of the base layout.
So this is base layout. So it's an HTML page with a title which has got block title inside it. Then there's a block head, a block replace style sheets, block style sheets. All these things are things you can add to your layout HTML to replace these specific sections within base layout. So the one we're doing is lab logo, which I got from the docs and doesn't seem to be there, which is brilliant, isn't it? Where's the logo? Oh, sorry. It's in the lab logo is an example of sending ad. Sorry about that. For layout, you would do any of the things that are there, such as the block libs and block title. Oh, my mistake.
But it's the same thing for the. You just use only once.
Yeah.
If you don't specify an add or a layout.html in your project structure, you'll just get the default Dallinger ones.
Yeah. So
you don't need one necessarily.
that's correct. Yeah. So if I go back to what we just had, and what happens is you get all these things that are in templates by default.
Mm-hmm.
So if you don't supply a where is that? Oh no, sorry. Okay, so you have to supply an ad, but it will be generated for you when you create a new experiment. But the reason that happens is because everyone always needs to make at least some changes.
Right.
So you don't have to create the file, but the file will be there. And that extends from add.html, which extends from layout, which if you don't provide, it will use this one, which extends from base layout.
I see. And I take it that there's some sort of Dallinger create experiment
Yes.
that we look at it.
Yeah, we're going to look at that later today.
Okay.
I've somehow managed to close the speaker notes while I did all that, so if you give me a moment. Cool. The other really common thing you might want to do is just change some colors, either the entire color scheme of the app or just to have a highlight color, say in headers or on buttons. There's two ways you can go about that. There's a static CSS directory where you can create any CSS files you want, and then in your layout HTML, you would do I think it was extra style sheets, or the style sheets block that we just saw in base HTML, and you would add a reference saying, I want to use this CSS, and then it would be pulled in. So anything you create there will be applied to every page of your experiment. The caveat there is don't call it Dallinger.css, because there is a built-in Dallinger CSS that just aligns a few things. There's maybe 10 CSS rules in there, but if you override that and you don't put those special Dallinger-specific rules in, you might have some things that look a bit wonky. So call it experiment CSS or the name of your lab CSS, whatever's relevant there. The other thing you can do is Dallinger's built on a CSS and JavaScript framework called Bootstrap. It uses version 3. Specifically right now it uses version 3.1.1 and 3.4 is the newest, but they're close enough that it's probably fine to just update that and it won't have any negative side effects. I haven't tested that, but I would expect that to be the case. And what's really nice about that is on the Bootstrap website, there is a form you can fill in where you give it all the details about all the styling you want to do, what fonts you want to use, how much spacing you want around things, what colors you want to use, and it will generate you a replacement for bootstrap.min.css that you can just put in your Dallinger static directory, and then that will replace everything without you having to go in and modify everything one by one. So that's a really good way of doing a broad theme with very little effort. Most of the things we're going to be doing are JavaScript based, because pretty much all the experiments use JavaScript in some way to mediate the communication between the front end and the back end. And one of the most important function calls there is create participant. When a user first comes to the site and they've agreed to be part of the experiment, they've consented, we need to tell the Dallinger backend that we've got a new person, and we need to get a participant ID from them so that that user can interact with the backend in a consistent way throughout the rest of the experiment. So create participant, you just call it on its own. The way most of the demos do it is on the instruct ready.html, which is the last bit of the instructions. they have this block script Dallinger create participant. And that will mean that once the page is loaded, it will make the call to the backend, and the Dallinger API JavaScript file will handle storing the data and making sure that everything is in place. So once this is there, the participant is registered and Dallinger knows about them. Before this, the Dallinger database doesn't store any data about them. So make sure it's after the consent page and you're sure that the user's there. Definitely don't put it on the ad page, because if you put it on the ad page, then everyone who even looks at the task in Mechanical Turk will get a participant created for them. And then the next one, which kind of it feels like it does the same thing, is create agent. There's the concept of a participant and an agent in Dallinger. An agent is the way a participant is part of a network. So a transmission chain, for example, is a network where you have, earlier we had 5 or 6 of us. We would take the input of a picture, draw a new one, and they'll be passed out. The way we were interacting with the API there wasn't as participants, it was as agents. And that's because it's possible to be part of multiple networks in one experiment. You can say, I want people to do 5 experiments and they have different info each time.
And so one example of doing that is when Tom Morgan and I have run these evolutionary simulations, which had 60 generations of 40 participants. In fact, we didn't want to just have our participant come to the experiment stage and make a single decision as part of a single network. We wanted to keep them around for a while so that they could, just perform a short session of maybe 15, 30 minutes. And so in fact, what we did was we ran 125 of those simulations in parallel. So that was 125 networks. So when the participant comes to the experiment, we create a single participant object for them. So they show up in the database as a single participant. But each trial that they do, hopping from network to network, we create a new agent for them. So in the context of that particular simulation, they are a different agent in each of them. So that's just an example of the distinction between a participant object, which is a single human participant in the context of a particular Dallinger server, a particular experiment, versus an agent, which is a node in a particular network.
Yeah, so you might only have one network, or you might have 100 networks. And you call create agent every time you want the actual user who is sitting at the computer to have a new role in a new network, if possible. You'll see this particular code snippet around in the demos quite a lot. The way create agent works is it will either succeed or fail. And it can fail for 2 reasons. It can fail because of a bug, or it can fail because the backend has decided that they don't want this human participant to do anything else in any more networks. So the way this works is you call Dallinger create agent, but instead of just putting a semicolon there, you call .done and give that a function callback. And that is the code that will run if the backend decided that it has some more work for that agent. So there you would make sure you store the node ID. The node ID is the identifier of that agent, because you need that to submit the work. So that changes every time you call create agent. So for every network, it will be a different node ID. And if you don't have the current one, you cannot submit that user's actions. And then after that, you have a fail, which checks, did this fail because it was a 403? And being a 403 is the code that the Dallinger backend uses to say, we've got no more work for this user, we want them to finish the experiment. So if it is, it says allow exit and go to the questionnaire. If it's not, then it's an error, so it calls the Dallinger error handling and says, okay, something went wrong, who knows what, but it's better to show them an error and give them a way out of the hit that still gets them paid. Yeah.
So we saw before ways of interrupting apart from pulling the plug, ways of interrupting the experiment in between. I think it was something like set auto recruit to false. And then what is the context with created participant and created agent?
It's a good question. Can I take it?
Yeah.
Right. So you could think of it in this way. Once a hit starts, Amazon actually take from you, requester, a certain amount of money, take it from your bank account in Amazon, and put it in some kind of secure place. Means that this is now a contract. The way Amazon is conceptualizing, it's really a contract now. For you, they hold that money, the requester is doing the job, and it's finished, the job is getting paid. So in this intermediate period, you're supposed to support this work. Now we are playing God's, because like the work is really relying on us to support it, right? So if you start working as a participant in an experiment and you got to 400 things, it means you finish all the available nodes and everything is okay, you're going to be taken to the questionnaires and then getting paid. If something goes wrong, right, then it will lead you to the end goal, and this by default gives us an email to complain.
Yeah.
And so what happens if I just do stop auto recruit off? That's the soft way to do it. All the participants that are still in the pipeline, it's going to be finishing. And as long as it takes maybe 45 minutes, an hour, it's fine. As long as the time that is you specify for that app is not finished, the thing in the top of the clock up there that I showed you. It's not done, then all those participants just go through the pipeline and then it's going to be softly ending.
If they time out, do they also get diverted to some complaining?
No, when they time out, it's their own fault. And they're not gonna, you're gonna see it as a notification, but they're not gonna supposed to get paid.
In fact, if they time out, they cannot get paid, but they can still get a bonus. And you can configure your experiment to give them a bonus in that situation, but we have no example code for that.
Yes.
That was done.
And as I see it, is a bad practice because usually I set a very, very long time for the experiments to do it. We can talk about it later for etc. But imagine that you shut down the experiments. Then everybody's gonna basically, well, they won't even not seeing that. They just see an error on Amazon. It's a different type of error. It's not even that, because like that is a route in your experiments. That's not even existing, but there still can be. They still have a way to complain. So it's going to be something in the Amazon MTurk thing that will allow them to submit a complaints for that particular worker, and they will do it definitely.
Yes, sir, but what I mean is when you set this variable to false.
What happens there is it will stop actively getting people to come to the app.
You don't come to create a participant.
Yes. So when they come to the app and they consent, that's when a participant is created. But once the participant's created, there could be between 1 and however many agents, depending on how you've written your code. What you could do if you wanted to is you could add a new variable that you can control through the admin saying, stop assigning new agents. That would be custom code, but it's possible to do. The idea is that the auto recruit stops new participants, and then the experiment is what decides. It gets asked by create agent, do you have any more work for this participant? And it can either say yes, no, or it can go wrong.
But another important thing is, sometimes and very often, you will recruit more participants. You will put ads for more participants than you actually have. So you basically now already say, I want 20 people working for me.
But you only define space in the experiment for 10, say.
Yes. Now what happens is Amazon, for them, it's already, this commitment has already happened. So they will allow participants to consume that, even if you set auto recruit to off. So if you decided to record 20 participants, maybe you have currently just 10 participants active, but Amazon will allow this other 10 still to go through.
So then create participant will succeed, but when they get to this step, it will try to create the agent, and the backend will say, we don't need you to do any work, so it will take them straight to the questionnaire without doing anything. So they get paid.
That's bad. Yeah.
Well, it means that you have wasted money, but because you've paid someone the base pay without them doing any useful work.
So the bottom line is doing such a thing in this code would be meaningless for the
Well, there is an advantage, which is that if you over recruit like this, your hit is more likely to have people sign up for it. So if you say I want 20 people, but you only really need 10, that increases how it will be viewed on Mechanical Turk. So you might get the users more quickly. But this particular code you would always have, because all participants go through this. And then this way you can have a loop, so you can say, I want them to do the same experiment twice, but with different pieces of start data. And you wouldn't have to change this at all, because it would say, okay, well, create the second agent. There is either no work available for them to do, or there is more work. And the JavaScript frontend does not need to know how many times the user is going to be given work. It can be completely generic. As long as it, after each bit of work, it checks create agent, is there more work to do? And then if there is, it shows it. If not, it moves on.
If you have a variable amount of work, you may consider putting the add HTML, a comment that say, sometimes you will get this approximately 100 trials, but don't worry, sometimes you guys just get less amount of those trials, and it's probably okay. You compensate it accordingly.
But
and that's very common. So that will guarantee that in the end game, when you don't have as much as work, that you still have participant playing in the game. And imagine that you do a transmission chain and you have like 100 chains in parallel. In the end, there will be a couple of chains only that will be free, so to speak, that people can play with them. So what happens is inevitably you have some end participant who will play just a few of those chains. And there's no way around it, because like if you don't do it, then the chains will not be full. And so you will need the participant to play lesser amount of rounds in the game, and that's totally fine. So you pay them a little bit more.
I know we're laboring this point a bit, but this is, I think, one of the more subtle and the more powerful things in Dallinger, which is that if you write your front end so that it doesn't know your specific experiment parameters, it just knows how the experiment works, and it checks, is the work to do? If so, let the user do it, and then repeats that until the work has run out. It means you can really easily make variants of the experiment that check different things without having to change the code at all, really. So you could say, I want to run this with 10 users once, or you could say, I want to run this with 5 users twice, and that is just a pure configuration change without any coding. So writing your experiment this way allows for a lot more flexibility in the future. The other side of that is when you create an agent, they're going to have information given to them to work from. So for us, that was the image. And we started off with that PNG image, and then the following ones were what the previous user had drawn. The way that works is this info object that we've mentioned a few times. An info is just a container for the data that a user either consumes or creates. You can write your experiment so that it can have any amount of data coming in and any amount of data going out. There's no specific rule there. I think most of the demos assume it's 1 bit coming in and 1 bit going out, but that is not a rule. So both the Bartlett 1932 Stories 1 and Iterated Drawing have 1 coming in and 1 coming out. That's the image you see and the image you draw. But you could, for example, if you had it so that it iterated through every single bit of data coming in, you could see maybe the last 5 images if you configured it that way, and then you have to draw a new one. This is another place where you can get a lot of benefit by being generic. If there is a way for you to handle, to display sensibly having multiple bits of data coming in, then it's really worth making the effort of doing that. Because if you just assume 1, which is what this code does, then you have a lot less flexibility when it comes later to playing with the details of how the transmission chain or the networks work. And as I mentioned earlier, it's text, so you can put whatever you want in, either plain text or JSON. JSON is probably the most common and what I would recommend that you do, especially because it's so easy from JavaScript. And when you send data, you send it as an info. We'll be doing that in a moment. And when you do that, you can pick the type of it and the content. So later on, we'll look at how to define new types of info. So you could say, okay, this is the data that I want to pass on to the next person, and the rest is just a bit of debugging or extra stuff that you want to look at. So for the Bartlett 1932 demo, where you type in the story, you might have the create info with the text of the story once you hit submit. But you might also be in the background sending create info for every time the user deletes some text. Because maybe what you actually want to study is how many times do people delete it, or how quickly do they type. So you can store that data using create info with a different type to the type that you have declared in the backend that you want to send. Is that a bit weird, or is it clear? No? Yes?
So this is called once per event? I didn't understand.
Yeah, so create info you can call as many times as you want for whatever reasons that you want. Generally speaking, you'd call create info when the user has finished their work and they have got the data in the same format that they received it in. So here, you have get received infos, you have this object with a contents attribute, which might be JSON, and then they do something, and you call create info, and the contents is what your user has come out with in the same format. However, there's also this info type. Here it is state. By default, it's info, but you can define your own one. That's something we'll look at a bit later. So what you can do if you want is you can say, this is the final result that I want you to pass on to the next person, because it is the state that I have told you is the one that you pass on to the next person. But you can also store a lot more data for your analysis that will not be passed on to the next person, but it will be in the database so you can look at it.
For example, every brush stroke of the drawing.
Yeah.
And you want to remember not only the final drawing, but the order in which they draw the picture. Then the way you do it, there won't be one final info, which will be the info that will be passed to the info. It's like, call it main info or state, say. But then there's going to be other ones that you can different class, say, brush strokes. And they will be just like that, but they will be separate. In this case, it will be just like, because it will be just images. But you can also make them different if you want. But even if they are just identical, it's still useful to give them different names, because then later on you could separate. These are all these intermediate states. I don't really care about them. This is the real info that went to the email.
The API automatically puts that into the tables by input type key.
You could be searching for that. It would be part of it.
We're going to go into detail a bit later on of how you create the different types and what defining relationships between how things work. But in general, yeah, you would create an info for the final state in the same format as the one you received, and you would create a different type of info for every time there is a bit of data you want to store for later analysis that you don't want to pass on to the next user. And these two are easy in comparison, AllowExit and GoToPage. AllowExit is one that you need to call before you move the user away from the experiment page or the consent page. What that does is there's a bit of code that prevents the user from accidentally closing the window. So if they try to close it or they try to navigate away, it will pop up a warning saying, oh, are you sure you have unsaved changes? AllowExit disables that so that you can cause it to move on. If you didn't call that and then you try to send them to the questionnaire, it would say to the user, are you sure you have unsaved, because you have unsaved changes, which is not what you want. GoToPage is pretty self-explanatory. The value is the same as the name of the HTML page. So you'd have GoToPage add, or GoToPage questionnaire, or GoToPage instruct ready, whatever you want. It's custom JavaScript, and that matches exactly with the HTML pages in your templates directory. And finally, error. We saw that briefly earlier. A lot of the functions that Dallinger provides to you have a done method and a fail method. In the fail method, you have function rejection, Dallinger error rejection. This pattern will mean that if it has failed, show the user this error, give them the chance to complain and say what they were doing, and then guide them back out into the making sure they get paid. So if you don't do this, the user might get stuck and you'll have to manually go in and accept the hit and pay them and deal with it. This tries to take some of that load off you. Any of these? Anyone have any questions?
So if you want to avoid potential complaints, you could catch errors and just redirect them to payment, minimal payment, or whatever.
Yeah.
And then basically you save this amount of work that potentially you have to handle manually.
It's never perfect, but that's the idea, yeah. So by doing this, you are trying to catch as many places that things could go wrong, and then you guide the user into telling you what happened, so you can check the logs and say, okay, well, why did this error happen? Rather than having to go back in and dig out when you get an email. But
then I don't quite get the syntax. How does this relate to some try catch?
well, these are error handlers for Dallinger API calls. So the create agent function up here is a Dallinger API function. When you call that, it returns a promise object in JavaScript that has two options. You can have a done function and a fail function. So done is where you put the code that you want to run after this has succeeded, and fail is where you put the code that runs after this has failed. So this is just saying, create the agent, put in the log done once it completes, but if it failed, then this is the error handler. So
Okay.
you might have more stuff in there,
Where
you
do
might not.
you filter by specific error type or error content?
You would have it in this if statement. So if you go back to this one, is it this one? No.
Yeah.
This one. So here it's saying when create agent fails, it can fail for two reasons. It can fail with a 403 forbidden, which is how Dallinger says this is kind of intended failure. It just means that this user has no more role in the experiment. So AllowExit and go to Questionnaire. If it fails for any other reason, then it's an error. So this pattern allows you to say, this is an expected error. I kind of thought this might happen, and I want this to be the result. Otherwise, show this. If you're catching an error in JavaScript with a try catch, you would just do Dallinger error, and it would send them to a page without any specific details of the error. It would just be like, something went wrong, tell us why.
And this rejection, Dallinger error rejection, will lead you to an error page, error.html. If you want to, for example, add a functionality that the participant is going to tell you what's happened or something like that, instead of just complaining, you can add that functionality to overriding this template. Straightforward.
So those are the things that you're always going to have to do at least some of when you're building JavaScript for your experiment. But there's a few other things that might be helpful that you probably won't use on every experiment, but if you're building a lot, you will use eventually. One of them's get experiment property. This lets you define things in the Python side of the experiment that are exposed to the JavaScript side. There's a function or a dictionary you create on the experiment called public properties, and that either returns hard-coded variables or it can run a bit of Python to calculate them. And this allows you to really easily pass, well, to request data from the server side without having to write custom API endpoints. This is commonly used for things like what's your current bonus for the participant, or what stage of the experiment are you on. You can call get experiment property to get this information out more easily. And yeah, it's accessed with experiment.public properties. So you can either do on your experiment class public properties equals and then the dictionary of stuff, or you can use Python's property function to create a function that generates this dictionary, which will then be exposed to the end user.
Can you actually demonstrate that feature? Because I think that's at least.
I'll try. I
for
haven't
you,
prepared.
For me, how do you expose something? Because that's something that previously I was naively using specific routes for that information, and now I realized maybe that's not the most efficient way. And so, for example, I create a bonus route and get individual like parameters, global parameters, route, and so a bunch of routes. And I think that's probably what you're proposing here is by far much more efficient than doing that.
So here in experiment PY, this is the one for Bartlett. Do we have one already? We did not. Okay, so you could do. That's the simplest one you can do. You can
So,
just.
sorry, that dictionary, there is only one in experimental file. It's a single location for the dictionary.
It's within the experiment class itself. So yeah, what you would, if I move up a bit, so it's a bit clearer. So we've got, yeah, like Max said. So you can do that, and that sets a static one just for that experiment. But what's more common is to do something like that. So here, because it's Python, you can do whatever you want to build it. Is there any useful information we have? I don't know. So obviously you wouldn't just have it getting a random color unless that was useful to you, but that, in theory, should offer a public property called color that gets a random one. And should we try running that, or is that too much of a looking like a demo? So we've got an experiment running here. I'm just looking at the homepage, not the experiment itself. Can I just do that? Will that work? No. Okay, I'll wait for the thing.
Okay, so the property annotation and then the function specific public properties.
Yes.
Expect basically not a JSON, a dictionary, right? And then that dictionary is basically copied as is to be a JavaScript dictionary.
Yeah, so it's passed out as a JavaScript dictionary.
Yeah, so you don't see the JSON. You already see it processed basically.
Yeah.
And then these values can be, but these values are computed on the fly. So it can, for example, look on stuff in the network or, right? So
yes, exactly.
but if these values are somehow dependent on the participant ID, that's a problem, right? You still need a route for that.
Yeah, probably.
So if it's a global parameters set up in the top, that's fine, because like it's like related to some status of the experiment.
Yes. What you can
But
do.
how do you do the bonus? You mentioned bonus.
What you can do is you can return a dictionary of all the current participants and their bonus.
I think that's
It's
a
not-
security
I
issue.
agree with that.
If that's a class field, this means that from JavaScript any user can access to the whole information in that dictionary.
They already can, but users can access a lot of things just with the JavaScript API. We'll talk about that later. Yeah. But what's it called? What was the? What's the name of that function that we were talking about? I can't remember anymore.
Yeah. So like if you want to have a bonus of a given participant as an information, then you basically need to create a specific route for that, right?
If you want,
Because like you want to separate it by participant ID, then
yes. So this is Dallinger.getExperiment property is the thing, and if I open that up, psychology experiment, yeah. Where are you? So get experiment property, color. That's like the others. It has a done and a fail, so you can do done, function, data, console.log data. Yeah. So here, state of success color green. And if I run that again, it's blue this time, or blue again, or red. So this allows you to write Python to get some bit of data that you can then extract on the JavaScript side easily.
Sorry, I have a question about how it's getting that. Like I noticed that it does it in like a callback sort of way.
Yeah.
Is it returning a promise or like?
Yeah, so it returns a promise that's backed by an HTTP request.
Okay,
Yeah.
so then in theory it should be possible to await, async await. So you can
Yeah.
await that as well, right? Instead of using .done.
Yeah, I
Okay,
think.
that's
I
great.
think.
Okay.
I think.
Because that would be really nice.
Yeah.
If you could.
If you can't do that, then there's no particular reason why you can't.
Yeah, I
Yeah.
see what you're saying.
Okay.
I
Yeah,
I just realized how important what you just said.
Yeah,
Because okay.
yeah. We'll talk about it
Maybe you can explain. I think it's it's a valuable.
I'd be interested. Yeah.
Yeah, explain why is that super important.
So for example, up there, let's look at that example code of the num experiment trials, right? So that is just an empty variable, and then you decide to go get that from the server, and then when it's done, you get a callback with that response, and then it sets that num experiment trials to whatever it is. The problem is that JavaScript keeps going. So for example, suppose you wrote it naively, right? Where you said num experiment trials, go get them, and now do all this other stuff below, because you think that it works like Python and just goes from top to bottom and it waits for the things. It doesn't wait for the thing. Basically, if you want to use that num experiment trials with that value there, you need to include it in that callback.
Yeah.
So your whole experiment,
Callback
your whole experiment needs to live in that .done. Your whole experiment needs to live in that .done. Whereas if you could await it, like if you could use async await, then you could just say await Dallinger.getExperiment property, experiment repeats, and then the code just runs like normal, like it reads like a human can read it.
Yeah.
Yeah, so instead, like if you naively code Dallinger at the beginning, like I was, the thing that you happens to have is this nesting down loops. So you write a number of functions, they're all nested into one another, because you have to, that needs to be done, and then calls that, and then that needs to be done, and then call that. So they have this kind of nested structure, which was very unintuitive.
It's called callback hell, because that's the term they use.
Whenever this starts forking, then your life is basically over, because as long as it's just a series of nesting, it's still possible to manage with human thought. But as long as it starts forking, that's game over. That's just debugging all the time. It's just never gonna work.
In an ideal world, that code would be reduced to var num experiment trials equals await Dallinger.getExperiment property. The end. That's all. In a slightly more idiomatic ES6 style of writing JavaScript. Is that possible? Top level await does not quite work.
Does it not?
Yeah, you'd have to wrap it in an async function. But okay, maybe it works in the console, but generally you have to wrap that in an async function. Okay, so that's really nice actually. But then that gives you back an object, so you got to do color dot color, right?
Yeah. And can you do that? I don't use JavaScript to wait.
Just do color now.
No, because the await gives a premise.
It gives it.
Yeah.
Okay, so
What is color? If you just did that, right? So that is itself an object. Right.
Yeah.
That's what I mean.
yeah, but it's not the end of the world. So
No.
basically, this await statement
Mhm.
in a serial, like if you have a series of things and you rely on this little bit there,
Mhm.
you add this await call, and now will basically sits there
Mhm.
and just wait for that to happen. Once that value information comes from this asynchronous behavior, it's keep executing. And then you, instead of writing these nested things, one on top of the other, you can write it just serially.
And if you're wondering why this isn't the way all the code is written,
This is Scrabble.
yeah, we started working on this in earnest 3-4 years ago, and a lot of the code is older than that. The front end best practices change so quickly. Yeah.
Yeah, this is bleeding edge stuff. It's like only in the last year or two that this has become a thing. But it's made it a lot more sane to do web development, this async await thing.
And I was wondering from the other corner of things regarding security and limiting users' access to the information of others. I don't know, I have never done an experiment, so I don't know to what extent it's meaningful to have this global dictionary store sensitive information. But you could maybe put that on a closure on the JavaScript end, and this would limit the access from one user to each other, because a class property is a pretty global
Yeah. So
information.
it's a good point, and it's something we have talked about in quite a lot of depth before, sort of internally. Right now, we're kind of still using the assumption that all experiment data is going to be public eventually, and if someone wants to actively damage the experiment, they will find a way how to. And that has been okay because, as far as we know, nobody has actively tried to cause trouble that way.
So the evidence tool.
Yeah, so yeah, it's kind of there is time in the schedule later on for talking about this in detail. So I think we're mainly part of the discussion for now, but I will say that it's something we are aware of, something that's on the to-do list, but it has not risen to the top of priorities because it hasn't been a real-world problem.
I think that there's two sides to it. One, which is a critical one to me, is are you exposing personally identifiable information of participants to anyone? And so it would be bad if we by default were sharing one participant's PII with others. So there shouldn't be like a global way to read all the MTurk IDs or some other thing. The second bit is, can you is more about like security on the writing side, which is, can anybody write arbitrary things to our database? If like the participant knew how to use the API, could they just write whatever they want? And that's another question which we can talk about later. In practice, we have had a few instances across all the experiments that have ever been run where somebody seemed to actually be trying to send HTTP requests to the server that weren't just created by them clicking on our interface. Generally speaking, there isn't enough to be gained by it. It's faster to spend that time just doing the task. I think the bigger security concern in that sense is that it's not a security concern as much as just that if somebody's trying to game the system, the best way to do that is to write a bot to do the work. And that is something that is like an active area of thought, not just in our groups, but all over.
And there are other ways I talk about it to avoid bots to be incentivized to do the work by bots. So I think it's pretty easy to find out experimental ways in order to get rid of bots. And then if somebody create this super thing reverse engineer your JavaScript, and all that to gain $1 once, because he can only recruit him like as a worker. He can use only once. So it doesn't all that work to get $1. He well deserve it.
I was thinking more about the examples like if you are, because of your experiment or your personal preferences, you are willing to pay twice as much money to people called Michael, and everyone else can find out. Well, you know, they might even, I don't know, take any action.
Yeah.
If you want to hide that.
But I think
It's
the problem with Dallinger currently is that because of debugging, we're still using JavaScript and we don't use obfuscation. So for most experiment, my sense is that it seems like currently the bottleneck is, the routes are exposed. But the thing that is exposed is JavaScript is exposed. So you can just go into the JavaScript code and figure out a lot of things about the experiment, in which that will be the main constraint. So, and I think if you want to harden anything, it would be the JavaScript, and there are ways to do it. You can use obfuscator, you can use framework which are a little bit harder and on the parts. But if you just use plain vanilla Dallinger, I don't think the weakest point is actually the routes. It's actually the Dallinger itself, like the JavaScript.
But don't you also log each of the calls, the API calls? So if you don't have a log,
so that's what I'm
you
saying.
can exclude.
This is why I'm saying in practice, when you start thinking of experiments, you discover that what people can do is like making some trouble for another participant. Everything is going to be deleted anyhow because they're not be smart enough to generate the exact structure of infos and the right sequence. They have to create an agent and then an info and then an agent and then an info. If they do anything in the wrong order, boom, they're end. They're at the end. So like it's really much more involved than you think to crack that thing for $1.
Yeah, I guess the high level answer to all of this is we're aware it's not perfect. It hasn't been a practical problem so far, so we have prioritized other things that have been practical problems.
I'm sure I was trying to keep it constructive.
No. I know, but it's I very much have an interest in security and privacy as well. So it's definitely a topic that we wanted to talk about this week.
I have a question just about the JavaScript. So I imagine that there's like a Dallinger.js or something that has all these functions defined in the Dallinger class. Is it like a node module like available at NPM, or is it just a?
It's bundled in with the experiments when you run Dallinger. It's documented in the main Dallinger docs. You can find it in GitHub as well. It's Dallinger2.js, but it's not separately bundled.
Because I was just thinking, like, not that this would make things completely secure or anything, but when it's if it were a node module, then in your build system you could always just like obfuscate things. Like you could uglify and minify the code so that now you can't just open a console and type in Dallinger.breakMyExperiment. You have to like really
we should add that
thing. Right, you have to look for like D!! dot XYZ and like try to figure out what's going on, you know?
Yeah, I mean, the thing is, all of these take time to set up and make
sure.
work.
No, I was just wondering if it already existed.
No,
I know that that's a very time-consuming process.
It doesn't already exist. If any of you have a particular interest in it and want to contribute it, then that is very welcome. Right now, it's probably like halfway down our priority list, as I understand it. Would you say that's fair?
Understandable.
I mean, I think there's a 50-50 shot that you could do that in 30 minutes. In that, like, the most general approach is, like, it's a problem that's not specific to Dallinger at all. It's when creating a web application, what is the process by which you just take an entire folder of JavaScript files and uglify all of them before actually uploading them? And I bet that that's a well worked out thing, and you could probably add it as, the place you would do it is like, there's the whole build process where it copies all the files into this local temporary directory and then creates a Git repository and then pushes that to Heroku. And so like right before it pushes it to Heroku, you'd add one additional Git commit to that repository, which is uglify all JavaScript assets.
Yeah.
And all it would need to do is preserve the API so that it doesn't uglify the names of the variables that are called externally.
But I mean, the problem with that still, I think, not that I have done it a lot, but a couple of times that's worked out, that you just look the GUIs, and even if it's ugly and hashed out, the GUIs are plain text and understandable, and then you can easily, if the flow is linear, you can easily reverse engineer that.
Yes, but again, the sequence, usually if you write your experiment well, it's going to be a sequence of event. You need an info and create agent, and an info and create agent, an info of a particular type, and a create agent of a particular type. And so my experience with privacy about that you can easily find ways to block individual data by, for example, giving the info. You can also store things in S3. So if it's a valuable asset, you just don't store it in the JavaScript. You just put it in the S3 with like unique name that is not known for other participants. So I think there's good practices that basically go around, that work around this problem, whether if you had to really solve the problem in infrastructure, you had to invest a lot of resources. In practice, you can basically block everything. And there's other security measures like data check and attention check that can basically block payment for people who are doing funky things. So you can block their payment and you can remove them from the data sets. If they are operating and there are other bots that are okay, the other users that are okay, they probably generate irregularity in the data. You can check this irregularity and then you can delete them. So we'll talk about it. This is a part of Dallinger. So part of Dallinger allows certain amount of the data to be corrupted and then prune this data away and continue. So if you have like 1% of the users who are doing this evil thing, unless they're very successful to imitate all the right sequence, then they will be filtered away and don't even affect the data collection. And to be honest, if they replicate again, if they replicated the whole sequence, $1 is there.
It's also probably worth saying that your experiment is just a web app. So if you are concerned about it just for your particular experiment, there's nothing to stop you using packaging up the version of Dallinger JS for your version of Dallinger and running a custom build script and obfuscating it however ways you like. Obviously, we prefer it if you contributed any of these things back to Dallinger so it happens automatically for everyone. But if you find that your experiment is being attacked, you can always just override the Dallinger JS and change things. And it's flexible. We haven't made this happen automatically because of the cost-benefit trade-offs. But if you thought that previous one was a potential for people doing nasty things, GetInfos is the real one. What this does is it retrieves all of the information that another node has submitted. And the node numbers are sequential, so you can, if you're being naughty, you could do data equals await Dallinger GetInfos 1, 2, 3, and just read out what everyone else has submitted. And again, the reason for this is we are viewing all the information that someone is submitting as it's at least eventually going to be public. If it's public before the experiment is completed, it might compromise the experiment in some way, but again, it's all logged. But this allows you to, in your JavaScript, do custom things outside of the transmission chain. So you might know that your node ID in a previous network was 4 and it's now 72. You could call GetInfos 4 to call back, oh, what did I do last time? Which users did I interact with? Who, like, what was the user ID of the person who drew this? Have I got the same person this time? Did I use a particular function last time and I now want to block it being available this run? This is not something that is used in pretty much any of the demos in any meaningful way. But if you do need to get a previous info or an info from another participant, you can encode that in the logic of your experiment and use this function to get it.
So Bartlett doesn't use that to get the previous participants?
No, what it uses is it uses the get received infos, which is the ones that are intended for your user to be working from. This is a more general, get all the ones this user created, or you can have the ones they received as well.
Okay. And what if you really want to block it, you can block it from the front end. So you can just block this route, make that route not return anything. I think like in most experiments, this will not be used, right?
It's only used one place in the demos, and that's used incorrectly. So
Yeah.
yes.
So in theory, you could just, if you're really concerned about that, you can just block it from the front.
Get transmissions. This is a bit of a weird one as well. It's similar to the previous one, which is when you've made an info and you send it on to the next person in the chain, that creates a transmission object to say, this info was sent from this agent to this agent, or from this source to this agent. Get transmissions allows you to find the things that have been sent. So you can use this to more easily find the infos, how the infos relate to a network. So you could say, you could use this to find all the infos that another user received if you have a complex one. Yes, sir.
Does this information, is this a hard copy? Meaning if I am sending around videos and I have, let's say, 100 users and I have this 100 to 100 matrix, will I get a copy of every video on the front end?
This gives you from node to node and info ID.
So it's the metadata.
Yeah. But you can get the information out using the API as well, but yeah.
Usually if you have a very large chunk of information, I think a good practice would be to actually store in the info just a link to a repository.
Yeah.
And this is what I think everybody is doing. If you think about it, if it's a little tiny icon, you can still store it in the info, but it's become a video, it's become a little bit. I mean, I don't know what the limit of the database, but it's not the right way to store.
Yeah, a good example is like with the Bartlett drawing app, we just stored the actual drawing data in the info itself. But if, for example, you wanted the user to upload a video of them saying something, what I'd probably do is use something like S3 and some existing file uploader framework that is known to work really well, and it'll give you back the URL to it, and then just store that URL.
So that's the end of the summary of the front end.